Welcome to my channel. So recently I've invested a lot of time and energy into studying how to shift and or change modern soil structures and ways of maintaining soil into something that's slightly better. And when I say slightly, I mean not mineral-based dirt. We have a interesting phenomenon happening where we are destroying the terrestrial or ground-based life systems faster than we can fix them. So I'm going to describe that right now. And I don't expect that everything that I say to be perfectly accurate, although we have to think about it. "2,000 years ago, we used tilling the soil to create grain harvests in what we consider Europe and the Eastern countries, not Americas. In those countries north of the equator, turning the soil was beneficial at some level. Towards the equator, the turning of soil is not as beneficial because there's a thinner layer of soil, because it's much more tropical. The soil gets consumed fairly quickly. And if you get into the Amazon or a system of high density forests, the soil layer is fairly thin because it's being consumed all the time. In the plains of the northern hemisphere, and I'm not discussing the southern hemisphere right now, in the plains of the northern hemisphere, there used to be a large volume of herbivores that would cross the plains, and they'd defecate and urinate and keep moving. And they wouldn't stay in one spot very long because there was a lot of predation upon them. There's a lot of predator pressure. And this increased their ability to have a herd number because they'd have healthier animals because they're always on the move. So it's much harder to get diseases. They didn't stay in one spot, so they didn't decimate their whole landscape. And they left a nutrient trail that plants and things could thrive through. In the modern agricultural age, we've taken the herbivore pressure off of the landscape, we've fenced it, and then we put in tilling machines that turn the soil over. And when the soil turns over, it loses a lot of its carbon, and it loses a lot of its humus material in the wind. Stuff just blows away, and you can see it every time you go by a farm and a tractor is going down the field and there's a big plume of dust that's being blown away by the wind for that tractor. And that's just one pass, and he does dozens and dozens of passes. He may do hundreds of passes a year depending on what he's doing and what kind of crops he's growing. And he may use 3 or 4 different types of tractors to accomplish his farming mission. And again, there's no nutrient cycle going back in. There's no herbivores crossing his land and leaving nutrient packages of feces and urine. So every year he has to go, the farmer, he, she, they, it, whatever, the farmer has to go through and put nutrients back into the soil. And the way farmers do that is they use a salt-based fertilizer in their spread, or they might use and that would be an NPK fertilizer, and that's usually bound up in a cadmium salt, and we can get into that another day. But having too much of one mineral like cadmium and or a sodium in your soil is going to degrade the soil and stop it from being able to give plants the nutrients they need. regardless of the chemical makeup that you have. When you oversaturate land with any chemical, it becomes a problem. They may also take fertilizer from cow farms, manure farms, where cows, defecate, but they're fed a lot of antibiotics and very low nutrient dense foods that are not diverse in the forms of grains and things that are fed to cattle. And then that turns into their feces, and then the farmer may take that mishmash and spread it all over his field as a nutrient to put down. It works, but it's a problem because in America we keep having Listeria breakouts, Salmonella breakouts, and E. coli breakouts, and plants do not create these bacterium. Listeria and E. coli and Salmonella come from chickens, cows, and pigs. And like Salmonella is classically associated with chickens. E. coli is classically associated with cattle. And then Listeria is from gut flora of almost any animal. And these do not grow on plants. They don't grow in plants. Plants do not create these bacterium. They don't thrive in plants. Plants pH is wrong. Plants temperature is wrong for maintaining E. coli, Listeria, or Salmonella. They can't survive on these plants. And we in America we keep having these recalls of meats and vegetables and root crops because there's this E. coli, Listeria, or Salmonella outbreak. And that's because they're spreading feces all over their fields at different times of the year, trying to get nutrients back into their fields. It's a problem. And it costs millions of dollars to do those recalls. And people can lose their lives over it. Darwin made a good point. In a properly managed field, earthworms can produce 40 tons of fertilizer for crop per annum per acre. That means 40 tons per acre per year, just from earthworms. When you till the soil, there can't be any earthworms because they get chopped up and turned over to the sun, and the water leaves the soil, and the arable material that the earthworms could crawl through is now compacted and it's more dense, and there's no nutrients to chew through because it's all been turned over and decayed. So earthworms can't survive in a tilled field. So there has to be a shift of thinking for farmers. For instance, here's a good example of something farmers can do that would instantly benefit them and require very little effort or time. For every 4 rows of harvestable material, they could have 1 row of controlled area that is like clover or vetch or something that they can control the spread of fairly easily and maintain that one patch. And that one patch never gets turned, never gets tilled. And every year they just put new vetch or new clover or new ryegrass in there. And then every year they can come along and chop the top of the plants off before they go to seed and just lay it down as mulch for the earthworms, and the earthworms would eat through that, and then all the nutrient from that one row would go downhill. They could do that every 4th row on their slope, because every farm has some slope, and so they have the first row would be clover or hairy vetch or some type of nitrogen fixer, and then 1, 2, 3, 4 rows of main crop, and that would be big enough for their tractors to go through, and then 1 row of clover or hairy vetch or whatever nitrogen fixer you have, and then 4 rows of main crop, and just keep doing that. And they could reduce their reliance on spreading manure or NPK fertilizers all over the fields, and probably reduce their costs. It's just one potential solution with a tillable system. Another one is, instead of tilling at all, they come through and they do multi-species of crops. They do their target crop, and then once they've taken out their target crop, they instantly put in a crop that is a nitrogen fixer, like clover, or like I said, hairy vetch, or ryegrass or something. Putting it back into the system and then chopping it off before seed heads come to fruition, and then putting in a new crop. And in doing so, their main crop goes to seed, and they can take that main crop, and the non-target crop, the non-main crop, is always mulched back into the system without tilling. They've got to cut it to the ground level and then lay it back down, and maybe compress it a little bit, or maybe punch it in a little bit, maybe just leave it alone. But it would be more effective than tilling everything in. If they can't get around tilling, they have to find a way to work with tilling and with other systems. That's just 2 potentials. I did a test recently in Cascade, Idaho, which is about midway up Idaho, and I had a thermometer. I had a temperature sensor, and it's an infrared temperature sensor, and I aimed it at the ground on a 97-degree day, and the ground was 150 degrees bare soil, and that's not good for plants. And then I went over 6 inches where there was straw and wood chips that I'd laid down in a trench, and I pulled the straw and the wood chips back, and I aimed the temperature gun at that. We're talking 6 inches of difference. Same sun, same everything else. And I tested the ground temperature there, and it's 78 degrees, or 76, somewhere in there. So 150 down to 78 degrees, it's a massive difference for evaporation. So it'd be wise never to let the soil see the sun, and to have that roughly 80 degrees of difference and be able to grow your crops. You'd have to water less, and there'd be less problems typically. This is some stuff to think about, because as agriculture progresses and we use larger machines, they do more damage to the soil, they're heavier, they do more compaction, water penetration is less. I've talked to farmers, and if they get 2 inches of penetration, they have a quote-unquote bumper crop. It means that they're going to make money that year. If they get 1 inch of penetration of water into their soil, they have a regular standard crop. My fist is 3.5 inches roughly. So that's 1 inch of penetration is their standard normal. That's 2 inches of penetration is a bumper crop. 2 inches of penetration is nothing in soil. It's nothing. It means they have to water every single day, over and over and over again. Their water bill's got to be enormous. Well, we are literally pumping our aquifers dry, trying to maintain agricultural systems. Whereas we could put cover crops in and reduce their water load dynamically. We have estimates, if everything's done properly and we use the right swales and the right cover crops and the right mulches and the right drip systems, we can reduce water consumption by 10 times. So for every 10 drops of water they use currently, they'd only use 1 drop of water. 10 to 1. It's a 10 to 1 ratio. So how much money would that save the farmer if they didn't have to spend all their money on water and machinery? This is a pretty significant topic. Land value in America, and California in particular, is extremely expensive. In Monterey County, we can sell a quarter-acre lot with a house on it for $1 million+ and not even blink an eye. So when a farmer buys an acre or 10 acres or 1,000 acres, he spent a lot of money to get that land. And then he uses a tool that turns his soil over, and it turns to dust and it blows away in the wind, and he loses that little tiny micro thin layer of soil to the wind, which cost that farmer a lot of money. And what we're trying to do is reduce the farmer's costs so he doesn't go out of business. And that stuff that's blowing away in the wind is usually the nutrient value of the soil, which means that every time the wind blows, he loses money because the value of his land just went down because the nutrient went down. And he has to add more fertilizer on and more water, and it's more compacted, and it gets worse and worse and cycles him out of business. We're trying to get him away from that, him or her, them, they, whatever. The farmer in question needs to get away from those costs and get back to something more sensible and realistic, and not have so many high costs associated to the application of their business. In the process of doing so, that means the farmer needs to be retrained. And so education is critical. What I do is I work with a system called Permaculture, and it trains people on how to have sustainable agriculture in their local communities, whether it's their house, their farm, the local parks and walkways, how we can shift non-perennial, or we can shift from annual species to perennial species for food crops, where we can take non-productive trees and cycle them out into productive trees where we get a production out of it, and it's beneficial to the environment, and it also produces food, and it's a time cycle. And we need to train farmers to think like this, because right now farmers are just going, the cost of fuel, the cost of diesel. In the last 10 years or so, the cost of diesel doubled. But the sales price of produce did not. So there's almond farmers in California that are 10th generation almond farmers that are going out of business because the cost of diesel doubled. Nothing else changed. Just the diesel doubled. When the diesel doubled, they couldn't run their tractors to harvest their almonds. It's too expensive. In the same moment, the cost of almonds dropped because there's so many almond farmers. Because there's overproduction of almonds, and diesel doubled. And almond farmers, the biggest almond farmers in California, are months away from bankruptcy if they haven't declared it already. And so we'll see a downtick in almond farms, which means less almonds in our grocery stores. And almonds are a very valuable commodity, and they're delicious. That being said, though, almonds are only one species of nut that we produce in California. It's only one crop. We have walnuts and grapes. I mean, in California, we produce everything. In Salinas Valley, we're the salad bowl of the world. In Gilroy, we're the garlic capital of the world. We produce more garlic in one location than anybody else. This is a serious subject, and it gets into the root base of why plants uptake nutrient and the loss of biodiversity due to mega farming and pesticide and herbicide use, fungicide use. And it turns out that most of the pesticides, herbicides, fungicides, and biocides that farmers use to maintain their one single crop is causing the downfall of the entire ecosystem, And it goes from funguses being wiped out, and 90% of all plants that we utilize have a fungal root associate to uptake nutrients. Go figure, that's a bad problem. You don't have the funguses, and suddenly the plant can't uptake nutrient, and it's stunted and dwarfed, has no nutrient value. So you need your funguses. You need the appropriate funguses. You don't want ones that are going to cause blight or rot. But you do need the appropriate funguses in your soils. 2, you need insects. And you know, it's really hard on the farmer when a single insect comes through and wipes out their crop, and the only way to wipe out that insect is to use an insecticide that kills all insects, including the bees and the wasps that actually control the other insects. Like, what are we doing? And then we wipe out the pest animals, the rats and the voles and the moles, with poison traps. And then the predators that were keeping those animals in check, the owls, the snakes, the cats, the large cats like the lynx and the mountain lion, the large predators eat the dead animal that's got the poison in it. Then they go off and die, and they don't reproduce. And then the pest population explodes out of control because there's no natural predators. So we have this downward spiraling effect of modern agriculture wiping out the very basis of what is giving it the production power to produce money. And it's right now we're going into 6X, which is the 6th largest extinction event on the planet, and it has to do with insects. We're losing a vast amount of biodiversity in insects every year, and it's because of the insecticide use and pesticides and herbicides, fungicides, and wiping out the things that were keeping the insects at bay. Like, you wipe out the ground birds, you're going to have a lot of locusts. You wipe out the you wipe out the bats, you're going to have a lot of mosquitoes. If you wipe out the predators and you wipe out the natural controls of these animals, you're going to have a bloom of the animal you don't want. It's going to grow out of control. So there needs to be some level of balance in association with farming and food production and the ecosystem. One of the things that we can do as individuals is we can eliminate the use of herbicides, pesticides, and fungicides, and biocides in general in our homes. That is the one thing that we as humans can have direct control over at our home level. We can shift to things like Paul Stamets has some great fungal associated insecticides. Basically, the agricultural system right now is stopping him from producing a fungus-based insecticide that could be commercially viable because they'd stop selling DEET and they'd stop selling their chemicals and their boron and their borax chemicals that would kill the insects. And that's to the home consumer. The Bacillus thuringiae tabs that go in the water and stuff, they'd have to stop selling things like that because Paul Stamets has a system of funguses that can actually control fire ants and termites and mosquitoes and all kinds of things. And he has the highest level of patents I've ever seen. I think he just got a general patent for everything for his systems. So and that's a natural product. That's just a fungus, and it's not harmful to animals or humans. It's just target specific to insects. And it doesn't seem to have any effect on positive insects like bees. So it's just the target insects. Another thing that we can do as homeowners is we can plant flowering plants, and I'm a proponent of planting a diversity of flowering plants, native, non-native. Me personally, I don't. We're not going to get around native, non-native. We're not going to sit there and say, "Oh, only natives in this area." You can't. There's such a huge species of non-natives in every area now because of global transportation of plants from one side of the globe to the other. America is a great example. North America didn't have the potato. Now we grow potatoes in Idaho. There's no potatoes in Idaho. That's a Peruvian thing. That's from Peru. Okay. Europe didn't have tomatoes. That was an American thing. They didn't have tomatoes over there. Tomatoes got shipped over there. They didn't have corn. Again, corn was from the Andes. North America didn't have corn. North America didn't have any corn. It's all from the Andes. They may have imported it eventually, and the natives got a hold of it here and started producing it, but that's from the Andes. Wheat comes from Europe, and yet vast swaths of North America are now covered in wheat. We consider it an invasive species except for the fact that we eat it. So there's a lot of products that we're never going to get away from. You're never going to get away from the eucalyptus tree in California. The eucalyptus tree is from Australia. Good luck getting rid of it. It's here. So I'm not a big natives, non-natives guy. You're not getting away from the non-natives. You can select out all the natives you want, plant them all you want. Me, I'm going to put in what I think is going to work for the local ecology. But farmers also need to think about that too. They need to work around their farms in a diligent fashion and learn from the gardeners who have success. And then we need to definitely set aside areas on all farms and home gardens that's just wild zones. In permaculture, we'd call it Zone 5. Zone 0 is like you and your house. Zone 1 is your first croppable area where you can use the closest area to Zone 0 where you can crop something like herbs and vegetables, annuals and things, and maybe some perennials. Zone 2 is going to be more perennials and more main crop, verging on maybe a couple like animals like chickens and things. Zone 3 is definitely for larger herbivores and milk goats and ducks and geese and things. Zone 4 becomes timber and it's closer to wilderness, less visited zones, and Zone 5 is left alone. So Zone 4 is like long-term economic crops like timber, lumber, crops that are going to take 50 years to produce their first crop, like walnut. Those are Zone 4. They're very low visit zones. The closer you get to the house, the more visits you have. And the more likely you are to tend something. So the closer you are to tending it, the more likely you're going to have success with it. And the less money you spend to tend it. The further away you go from your house, the more money you have to spend. So this is very critical, and we need to teach farmers this from the gardening standpoint. Farmers may have 50 to 1,000 acres, but they need 1 or 2 acres just for their family. And they need their family to maintain that. While the rest of the economy goes to their farming system, and they'll learn from their garden what to do on the broad acreage of their farm. One of the things that we're learning about is carbon penetration in soils. We need huge amounts of carbon in soil. We need more than 3% soil mass to be carbon. If you take the funguses alone out of the soil, you took 30% of the available carbon out of the soil just by removing the funguses. And carbon is a great sequester of water, nutrients, biological life, organisms, things that would make the farm actually work better and be more productive at lower costs. So we need to get more carbon into the soil so the farmer can have more of a bumper crop, because 2 inches of penetration is nothing. The farmer needs like a foot of penetration or maybe 2 feet of penetration of soil to get really good, sustainable agricultural crops. And we can do that using swales and hedges and vedges and other systems than just tilling. If you like this kind of content and you want to talk about it more, you want to leave a comment below. If you really, really like this content and you want to see more of it, you want to like and then subscribe to this channel. And if you really, really, really like this content and the things that I'm talking about or sharing with you, share this with a friend. The more times we share this, the sooner it gets global, the sooner the thought process goes to other people, and the more likely we are to change something in a more positive and or beneficial way. Again, if you have comments or concerns, comments. Have a great day.